Hello, everyone. Welcome to today's EEA Educational Series webinar. My name is James Harsh, and I am the EEA Membership Specialist. Today, we will discuss an update on Ethereum's transition to proof of stake and other important network updates. Today's call is being recorded and will be available to all attendees and the public on the EEA YouTube channel after today's presentation. The Enterprise Ethereum Alliance enables organizations to adopt and use Ethereum technology in their daily business operations. The EEA empowers the Ethereum ecosystem to develop new business opportunities, drive industry adoption, and learn and collaborate with one another. We welcome any and everyone to join and become part of our global community. At this time, I'm pleased to introduce and welcome back our speakers, Tim Beiko of the Ethereum Foundation and Pooja Ranjan of Ethereum Cat Herders, back by popular demand. Pooja, are you want to come on screen here?
Thanks, James.
Great to have you back. I'll hand it over to you. Thank you.
Appreciate the invite for the EEA Educational Webinar Series. This is my third time being with this amazing community since January 2021. So thank you for all the love. My name is Pooja Ranjan. I founded etherworld.co, a blockchain content publishing website where we share information-rich content and information related to Ethereum and other blockchain. As a herder-in-chief of Ethereum Cat Herders, I spend most of my time in communication, coordination, education, and community building around Ethereum ecosystem. Ethereum Cat Herders is a decentralized project management and process improvement group for Ethereum blockchain. Working with the EIP authors, EIP editors, core dev coordinators, client developers, we create educational content to increase the reach of improvement proposals and network upgrade. In the talk today, we will follow the latest on the merge and some of the EIPs in active discussion. But before we get there, let's meet Tim Beiko.
Everyone, my name is Tim Beiko. I work at the Ethereum Foundation. There I run what are called DL Core Devs calls, where we get protocol developers together to discuss changes to Ethereum. And then I spend a lot of my time also talking with the broader community about the Ethereum roadmap and what's coming up.
Thank you, Tim. I would like to now try sharing my screen here. All right. So for today's talk, we are going to be talking about Ethereum Roadmap, the merge, EIPs, and process improvement. And we hope to cover these 4 different topics. The first one is Ethereum Roadmap. On the first anniversary of Beacon Chain, 1st December 2021, Vitalik Buterin shared this long-term roadmap with the community. He writes, here's an updated roadmap diagram for where Ethereum protocol development is at and what's coming in what order. So as you can see, this is a detailed and long-term roadmap talking about 2 to 5 years down the line. It talks about the merge, the surge, the verge, the purge, the splurge, all rhyming nice and sweet words for people who are relatively less technical. But for people who are involved in active development are really happy to see this long-term roadmap. The shades of green here are the progress already made. Kudos to the Ethereum R&D team and Vitalik Buterin for being visionary. Today we will be focusing mostly on the merge. So starting up with the network upgrades. If any of you were present in the last talk that we shared, I showed you this diagram at the bottom of the screen. Not much has changed since then, except we moved merge to Q2. Shanghai, the next upgrade, is most likely to come after the merge. We will talk about the merge and Shanghai in a bit. You can also see C star here. Chances are the developers will go with a unified name for Shanghai because all the proposals are up for Shanghai irrespective of Ethereum client's layer. However, there is this precedent of using alphabetic star name for a consensus layer client. So I assumed it and I added it here. We will get to know more when we are close to the upgrade. Full disclaimer here, this diagram is 100% based on my understanding of Ethereum Roadmap and is not an information shared by the Ethereum Foundation or any other client team for that matter. Let's move on to the great renaming. In January, Ethereum Foundation shared a blog post to talk about the renaming of the layers that took place. Tim Beiko created a HackMD with all the renamings, not only related to layers, but also related to the communication channels, the Discord communication channel. On a very high level, Ethereum after the merge will be a combination of execution layer and consensus layer. Execution layer is what people refer to as ETH1 or Ethereum mainnet or Ethereum proof of work chain. And consensus layer is the Ethereum 2, the beacon chain, or the Ethereum POS chain. Going forward, developers may not be using the term ETH1 and ETH2, but the term execution layer and consensus layer. These are the proposals up for Shanghai upgrade. For Shanghai, there are 5 proposals already considered for inclusion and rest all are under discussion. They are broadly categorized under different category. Proposals are there for EVM improvement, validators withdrawal, lowering roll-up transaction fee, and there are some other proposals for other network improvement and protocol development. If people remember the London upgrade, that upgrade included a proposal EIP 3541, which was the groundwork for the upcoming changes with EIP 3540 EVM object format. We should expect more enhancement on EVM side with all these proposals listed here. We'll have an overview of some of the EIPs in upcoming slides.
Cool. So now I can walk you through the next upgrade that's planned for Ethereum, which we call the Merge. And I'll give you kind of an overview of what this actually entails, you know, what happens during the merge and roughly where we are in the process. Can move ahead. So at a high level, what an Ethereum client will look like after the merge is the combination of the clients currently running on the beacon chain, so a beacon node, which we refer to generally as the consensus layer of Ethereum, and an execution engine, which is today basically what we'll refer to as an ETH1 client. So the merge is really the process by which we take the current clients running on proof of work and we get them to, instead of listening to proof of work as their consensus algorithm, listen to proof of stake, which is managed by the beacon chain. And in order to one more thing on the previous slide. Yeah, in order to enable this, we basically introduce an API between the consensus and execution layer, which we call the engine API, which sends calls from the beacon node to the execution engine. And so this is, broadly what it will look like. If you're running like a full Ethereum node, you're going to have a beacon chain component to it and an execution layer component to it, both of which is basically the software that is known and available today. So, we have software like Teku, Lighthouse, Prism on the beacon chain. We have software like Aragon, Geth, Methermine, and Besu on the execution layer. And so it'll really be the combination of both those two things that represents a full Ethereum client post-merge. And it's worth noting that all of the kind of experience of using those clients will remain pretty similar. So the JSON RPC APIs will all still work as they do on the execution level, and similarly, all the beacon chain APIs will work on the consensus level. Okay, yeah, now we can go. And if we zoom in a little bit, what this looks like is that after the merge, we'll be producing blocks on the beacon chain directly and adding kind of the execution content of current proof of work blocks into that. So the image you see on the slide here has like two kind of concentric blocks. The larger one, the consensus layer, is what you have today on the beacon chain. So everything, the slots, the state root, the signatures, the RANDAO, the attestations, deposits, and exits, this is what the beacon chain already comes to consensus on today. The big difference is there's not this execution layer component to it. So it comes to consensus on all of this data, this, you could call it almost like metadata about the beacon chain, but it doesn't actually run transactions in the EVM. And so after the merge, we're going to add kind of the transactional content of blocks that are currently on the proof of work chain as part of the beacon chain blocks. And so in practice, what you get there is a little bit of data. So about the state of things, so the state root, the current base fee, the hash of the previous execution block, and most importantly, basically the list of all the transactions, which is kind of the core of what we do on Ethereum today. And from an end user perspective, though, nothing really changes because you still have these transactions that are executed in blocks within the EVM, and so applications and smart contracts basically keep running as they do. There's three minor things that are worth noting, though. So the first is that in proof of work, we have a block time which targets an average of 13 seconds with a lot of variance. So just because of how proof of work works. But on proof of stake, we have blocks coming exactly every 12 seconds. So there's a bit more of like a predictability there, except if a validator basically misses their block proposal slot, which currently happens less than 1% of the time. So it shouldn't be like a major thing. There's also a bunch of fields in the actual execution block that are set to 0 because they don't really matter anymore. So anything that has to do with proof of work or uncle blocks and all of that just gets set to 0. And the reason there is it's much easier to set fields to 0 in a block than to remove them, because if you remove them, you break the structure of the block and that breaks all of the tooling. And then lastly, the one kind of change we did actually do is there is a difficulty value in a block, which is exposed in the EVM through an opcode called difficulty today. And people use this as a source of pseudo randomness in smart contracts, even though it's not true randomness and it's very biasable by miners. People use it in practice. And so we wanted to make sure that we're still providing some source of pseudo randomness in the EVM rather than providing a 0 value every time, which would be pretty terrible for any contracts that try to have semi-randomness. So instead, we're going to change what that opcode returns. It won't be returning the difficulty value anymore. It'll be returning kind of the RANDAO value from the beacon chain. And one thing that's nice there too is the difficulty value is a 64 byte number, but the Prev RANDAO one is 256 bytes in length. So if you want to know within a smart contract whether the merge has happened, you can just call this opcode and check the size of the output value. And if it's 64, then you know that you're on the proof of work chain. And if it's 256, you know that you're in a post-merge context. Okay, we can move on. So what happens basically in the actual transition to proof of stake? So one thing to note is that unlike previous network upgrades on Ethereum, we're not using a block height. So, as you've probably seen in the past, when we usually upgrade on Ethereum, we say at block X, we apply the new rules. But the challenge with this is that block height works as long as you're under proof of work. But if you switch your consensus algorithm from proof of work to proof of stake, you want to make sure that it's very hard to kind of fake the last proof of work block. And if we use the block height, you could have something where somebody kind of shadow mines a bunch of blocks under proof of work, lowers the difficulty of the network, and then once a transition happens, kind of reveals that side fork, and it upsets everything. So instead, what we do is we set what we call a terminal total difficulty. So the way proof of work works, every block kind of adds a difficulty amount to the chain based on how hard it was to mine. And that gets calculated in the total difficulty value. And this is like an ever increasing number because it's basically, you take the previous total difficulty, you add the current, and you get the new one. So there's no way it can go down ever. And what we do is we set basically a terminal total difficulty, which says once we have a block which has a greater or equal than total difficulty than this value, we consider that to be the last proof of work block, and we then transition to proof of stake. And one thing that's worth noting is you could have different blocks which exceeds that. So, in a benign case, there might be literally an uncle block and a canonical block mined at the same time, which both meet this criteria. In like a more malicious case, you could think, miners will mine a bunch of competing blocks at that height. But the thing that's worth noting is that we only consider, the ones which exceed, the ones who exceed the terminal total difficulty for the first time. So if your parent has exceeded that, you're by default an invalid. So it means in practice, we're only going to have like a small set of blocks to choose from as the final proof of work block. I suspect it'll probably be 1 to 3 in a normal case, and maybe if there was like some malicious attack, you could see as many as like 5 to 10. But then you basically have the proof of stake validators vote on it, because all of those blocks are valid. There's, as long as, again, they meet that criteria, you can pick one of the final proof of work blocks, attest to that one, and that becomes the one which gets marked as the final one. And then after that, the consensus has moved to the proof of stake side. So there's nothing more than like the proof of work side can do to influence the final block. So that was basically the second bullet. Once we see a block that has a total difficulty bigger than the terminal total difficulty, the validator kind of can deem that one as the final proof of work block, and the next block gets created directly by a validator on the beacon chain. And then what we want to see to know that the merge has happened smoothly is you want to see that first block created by a validator on the beacon chain become finalized. And on the proof of stake side, basically finalized means that unless there's the proof of work equivalent of a 51% attack on the network, that block will never be reorged. So if you're an exchange, if you're somebody who wants like extremely high assurances that your transaction is final, that's what you want to wait for. And then at that point, the transition is basically complete. And one thing to note is that even though we are waiting for these finalized blocks, transactions keep happening throughout the entire process. So there's literally no downtime from like a smart contracts point of view. Whether you're on the last proof of work block or the first proof of stake block, it doesn't matter. If you have a transaction that's like, waiting on something to happen in the previous block or whatever, like it should all be instant, and there should be no kind of downtime or lag felt in the smart contract world. And I have a graph here that kind of shows you how this happens in practice, kind of taking together the things we just went over. But if you go all the way to the left, you can see this kind of the world we're in today, where we have the beacon chain at the bottom, which has all this consensus data about proof of stake, but doesn't have any actual transactions. You have proof of work at the top, which, there is still some like proof of work overhead, but then the execution layer within that is the bit where we have all the transactions be executed. If you move, one block to the right, you could imagine that the proof of work block we see there would be the one which exceeds the terminal total difficulty. So it would be the last proof of work block. And then right after that, if we move to the third block, you can see that the proof of stake chain is producing the next block, which has, the execution layer contents, and is still referencing kind of the parent on the proof of work side. And then, a block after that, we're basically, solely focused on the proof of stake side for both the consensus and execution layers. And so that's the overall architecture. In terms of actually deploying this, what does it take? So proof of stake has been in the works for several years. And I think it's really in spring of last year that it got to a point where we felt it was ready to be moved to production. And at that point, the beacon chain had been live for a while. There were tens of billions of dollars secured in it. We knew that it kind of worked as expected. So we really started to see, okay, how do we ship this thing? And so we had this hackathon called Rayonism, where the goal was to prove that we can actually get this like post-merge architecture where, you know, the consensus layer is managing all the consensus stuff, and then we get this execution layer to just run the transactions, and they communicate with each other, and it works. So we proved that around May or June of 2021. Obviously found a bunch of like issues and bugs and whatnot during the process. So we spent the summer fixing those. And then we came to the fall, and what we wanted to make sure worked was the transition from proof of work to proof of stake. So we wanted to, you know, to know that like we could go from one to the other, that the transition would work as we expected to. So we got everybody on the client teams together in person and spent a week kind of prototyping that and managed to get a network that did transition through the whole thing. And then obviously again, found a bunch of bugs, spent a couple months fixing them. And towards the end of the year, so in late December, we had Kintsugi, which was our first public testnet running post-merge Ethereum. There, you know, we were pretty confident that the overall spec was good, but we knew there would probably be issues. We found some and we fixed them. Yesterday, we launched kind of Kiln, which is what we expect to be kind of a spec complete testnet running post-merge Ethereum. You know, at this point, we're really looking for client implementation or tooling issues, and we found a few yesterday. But that's, you know, we don't expect the specification or the architecture to change significantly from here. Obviously, there might always be some implementation issues, and that's what we're looking for. If you do want to participate in helping, you know, the merge move forward, you can use Kiln. I linked the blog post today. I linked the blog post on the slide. If you go to blog.ethereum.org, it's basically the latest one. And you know, there we'll walk you through how to get started if you want to just use it on MetaMask. If you're an application developer, you know, deploying your smart contracts on Kiln and making sure they work as expected is a really good idea. If you're a tooling provider, you want to make sure that your stuff works in kind of a post-merge Ethereum context. I think this is really the time to do it. You know, we might find some small issues and bugs, but we don't expect significant changes. And if there are major tooling issues, this is when we'd want to find out. And so once we're pretty confident that like Kiln is stable, that, you know, we found their implementation issues and that tooling is set to support the merge, then we would upgrade existing testnets. So Gordy, Rothston, and whatnot, we'll run them through the transition like we do with any Ethereum upgrade. And then finally, mainnet is what we would do after, once we've seen these testnets kind of successfully transition. And I think, yeah, that's all I had on the merge.
All right, I can take up this section. Ethereum Improvement Proposal. So I wanted to go a little bit more on like high level of some of the proposals that are in discussion, and probably some of you may want to follow in future to learn about the future enhancements with Ethereum upgrade. Merge includes basically two proposals, EIP 3675 and EIP 4399. EIP 3675 talks about the architecture that was just explained by Tim Beiko, and EIP 4399 is supplant difficulty opcode with Pravran DAO. Let me talk a little bit more about this particular proposal. So it exposes beacon chain randomness in the EVM by supplanting difficulty opcode semantics. In simple words, it is going to replace the uniqueness generated through difficulty with randomness generated with the beacon chain. And this will be accessible by the EVM. This proposal, of course, brings the breaking changes for application with logic that depends on difficulty opcode. But the positive side of it is the accessibility of this randomness to EVM allows many applications to implement just a small chain with this proposal and continue working with their dApp the way it was working earlier. We have recorded both EIP 3675 and 4399 with Mikhail Kalinin. So people who are interested to learn more about these proposals and understand how the working works on a very high level, it's a good watch. EIP 2124, fork identifier for chain compatibility checks. This proposal is not a part of actual merge, but it still is a requirement for EIP 3675. What it means by requirement here is like whenever a proposal is pushed to move to get to a final status, all the EIPs which are needed to run this proposal to make the deployment successful should be listed as required section. And this is one of those proposals. EIP 2124, the fork identifier, it is a number which contains the genesis block hash and block number of scheduled hard fork that have occurred in the network. It should not be confused with the network ID. I have added the example of network ID like 0 for Olympic, 1 for Frontier, that is commonly used, but it is a different unique number which contains the details of the hard fork. And it is very helpful for developers working in different environments, say for private network environment, and if they would like to understand if that is the real mainnet, Ethereum mainnet, or just the private networks, it helps differentiate these things. Again, we have got good resources available for you, and this particular proposal is in final status. EIP 4844, shard block transaction. This proposal is a relief for people getting anxious about high transaction cost. This EIP proposed changes to enable layer 2 transaction to be significantly cheaper. Please do not get confused EIP 4844 with 4488 that was earlier proposed by Vitalik. It sounds very similar, but it has different utility here. This proposal introduces a new transaction type called the blob, and this is added to the Ethereum beacon chain, not to the execution client. Blobs are 4096 field element of 32 byte each, and maximum 16 blobs can be added per block. These are added to beacon chain clients, but are pruned after 1 month. That is long enough for all the actors of layer 2 to retrieve it, and short enough for people who are willing to run client node, that they don't have to go for a high disk. The disk usage is manageable. So adding this small amount of data to the Ethereum client, Ethereum will enable users to have less than 10 cents for most of the transaction without sacrificing the decentralization of the network. So this is kind of revolutionary proposal. Blobs are not required for EVM execution. That means sync is independent, and again, it will be pruned, so that is trivial. Proto Lambda, an Ethereum researcher working on optimism, worked on a prototype in ETH Denver this year, and later created a meta spec for EIP 4844 to keep track of progress and summary. This proposal is in early draft stage, and it's not certain that it will be getting into Shanghai in the current form. However, the meta spec will help the iteration, and most likely this or some other version of EIP 4844 may be expected with the Shanghai upgrade. Validator withdrawals meta spec. As name specifies, this is a meta spec for beacon chain withdrawal for staked ETH. A HackMD file is initiated by Alex Stokes that suggests the possible workflow of the withdrawal process. So beacon chain was launched in December 2020. That enabled validator to stake ETH and participate in the network by maintaining the security of the chain. Till date, this is only one-way process. That means people can deposit their ETH, participate in the network. But there is a good news for people waiting for the withdrawal of the staked ETH for a very, very long time. Danny Ryan and Alex Stokes proposed these 3 different proposals to enable withdrawal. EIP 4863 and EIP 4895, these are push-based proposals, meaning the origin in the beacon chain and the proposal will flow unidirectional. The high-level flow of withdrawn ETH is from consensus layer to engine API to execution layer. This meta spec assumes the consensus layer will handle all the security concerns. The withdrawal, the partial or full withdrawals are triggered when certain conditions are fulfilled. When these conditions are met, a receipt of this action is placed into a queue that is sent to beacon state. This receipt contains necessary information that is needed to maintain the log for withdrawal, as well as it includes the amount of ETH withdrawn in Wei. The receipt also contains an indexing that uniquely labels the withdrawal instead of all withdrawals. The third proposal, EIP 4788, is a pull-based proposal. That means it works the other way around. The pull method seems to be less liked by the client developers. However, a decision on which EIP to be pursued for withdrawal is yet to be taken. Given all these proposals are fairly new, we can expect multiple iterations. And in order to preserve history and provide reference, this HackMD file initiated by Alex Stokes sounds an interesting idea to keep track of all those things. Nevertheless, the good news is that the wait for withdrawal staked ETH will be over with Shanghai upgrade. For curious cats, I have planned a peep and eat meeting with Alex Stokes on this topic on April 5th. So stay tuned.
Cool. And the last thing we want to discuss is basically process improvements to the EIP process and just generally Ethereum upgrades. So today on the execution layer and like proof of work Ethereum, we use core EIPs to specify changes, and those are built or like drafted on top of what is expected to be the latest specification, the yellow paper. And because these are two kind of, because the formats of EIPs in the yellow papers are very far from like the code that actually gets written on Ethereum, when the beacon chain got started, the consensus layer folks decided to instead create an executable specification, which is basically a Python implementation of the actual beacon chain, which is optimized for readability rather than than performance. Today, this this brings us into a world where like we have three different processes almost, where we have the EIPs, we need to maintain the yellow paper, and we have this executable spec on the consensus layer. And ideally, we'd like to harmonize this so that we can coherently explain like what is the process to make changes to the Ethereum protocol. And luckily, there's work that's begun on the execution layer side to create also an executable specification. So this is still being worked on, and I suspect we'll take several months to finalize. But at a high level, what we're trying to achieve is requiring both the execution layer and consensus layer to use the core EIPs to specify the English portions of their change. So things like just the abstract, the motivation behind it, the rationale, all security considerations and whatnot, which is great because it kind of keeps the accessibility of EIPs where it's easy for people to kind of dig them up and read them and discuss them. But then we want to move the technical specifications for both execution layer and consensus layer specification into executable specs. And what we get by doing that is that it makes it really easy to specify a change in a way that client developers are able to quickly understand it. So, and then obviously you link those executable specs back in the core EIP. Yeah. So we still have a few things we need to figure out. The first is like, what do we do with non-core EIPs? Because, if we do have this process divergence, it becomes harder and harder to keep it all in one place. ERCs specifically are quite different. So it might make sense to just split those out in a separate repository. The other thing that's really important for us to keep in mind is, how do we keep things easy for EIP editors? We don't have a lot of them, and they're volunteers. So we want to make sure we don't burn them out. If you're listening and you're somewhat technical, and by somewhat technical, assume able to read a specification, no need to be able to implement it or whatnot. This is like an extremely high leverage thing that you can do to contribute to Ethereum. If that's something you want to do, please reach out to me. You can email me tim@ethereum.org. and I'm happy to help you get onboarded there. But that's really kind of our biggest constraint, is just making sure that we don't put more work on our current volunteer editors, because we really can't afford to lose them. And then the last thing we need to kind of work around is the fact that basically most EIPs never make it onto mainnet, but we do want to keep a historical record of them. So how do we balance, not exposing too much of this like spam relative to what's on mainnet for people who actually just want to see what's part of Ethereum today, but then also, make it easy to keep all of these proposals, because not only for historical purposes, but because some of them often get referenced years down the line with tweaks and whatnot in a new proposal. So that's all the stuff we're kind of working through. Again, I think if this is something that interests you and where you feel like you can kind of help with some specification work, there's really huge value to provide to Ethereum by getting involved here. And yeah, that's it. I see there's one question in the chat. We can start there. What metrics will we be monitoring during the merge? There's a few. I think first of all is we want to make sure that we actually get. So yeah, I guess walking through the whole process, right? We'll be monitoring for sure hitting the terminal total difficulty block, and that's kind of what everybody will be looking at to make sure the merge is happening. Once we've hit that, we want to very quickly after, so call it 12 seconds after, see a block that's produced from the proof of stake side, which contains transactions. Once we have that, we want to make sure that we keep seeing them, right? It tells you something if the first validator got it right, but you want to make sure that all the subsequent ones get them as well. So we'll be monitoring that, and then in addition to that is you're monitoring all of the health metrics that you are already monitoring on the Beacon chain. So things like the attestation percentage and inclusion rates and whatnot. So that basically tells you that not only are we producing blocks which have transactions, but we're still coming to consensus on them effectively. So yeah, just basically monitoring hitting the TTD, then making sure that we are producing blocks with these transactions at roughly the same rate as we're producing blocks today on the Beacon chain, and then making sure that all of the kind of consensus related metrics around the Beacon chains, such as attestation inclusion, stays roughly the same.
Any other questions out there? Oh, there we go.
I mean, yeah, right. So when do we expect the merge on mainnet? It's hard. It's hard to know. Ideally, sometime this summer. This is kind of the everything goes right timeline. The thing that's hard to predict is unknown unknowns, right? If we find a critical issue tomorrow, then obviously we'll delay things. So we focus on making sure the network is secure first and foremost, and once we're confident in that, then we'll set a date. But I think roughly sometime this summer is what we're expecting. And related to that, is there a rollback plan in case of catastrophe? So no. So there's no way in the merge to go back to proof of work, right? And there's a couple of reasons for that. One is the proof of stake network is very resilient to some failures. You can literally have up to a third of validators failing and things working correctly. So we have a network that is built around the assumption that some intermittent failure happens. And the thing too is once you end proof of work, even first of all, it would be incredibly complicated to have a mechanism to switch back. But even if we did, you can't guarantee that the hash rate is there. And because of the security properties of proof of work, it's if you switch back, but you're not sure that there's actually enough hash rate for your coin, or there might be too much or not enough, that's incredibly insecure. So yeah, the plan is really you move forward to proof of stake. The proof of stake is the proof of stake consensus is kind of set up to handle things not working 100% perfectly, and we've always had that in the Beacon chain. Which clients will have to be used for the merge? So yeah, I think this is the thing that's really great is all the clients that exist today will keep being used. So if you're running, Geth today, or Teku or Nethermind or Besu, or sorry, Teku's a beacon chain client, but like any other execution layer client, you can keep running that after the merge. You will need to, in addition to that, also run a beacon chain client, because that's what tells you like the head of the network. So say you're running Geth, you're going to need to run like Geth in Teku or Geth in Prism or Geth in Nimbus or something like that. But because of the architecture we chose, Geth and the other execution layer clients is still going to be the piece of software that processes transactions and runs the EVM and whatnot. No comments on like the proof of work ban stuff. EIP editors. So basically, what EIP editors do is at a high level, make sure that the EIP submitted meets the guidelines, right? And the very, the very, I guess, like trivial way to describe this, and in practice it's a bit more involved, but it's just you're making sure that like all the sections in the template are filled with the information that like they should have. You're not making a judgment on the technical quality of the EIP. You're making a judgment on like, did this person check all the boxes when filling the template? And the reason we have it this, kind of this permissive and like simple is to make it easy for EIP editors to do their job. So if people want to like share that in the newsletter, again, feel free to add my email directly and tell people to reach out to me. I'm happy to walk them through, and we have current editors who could, walk through like what they do in practice. But at a high level, it's like you open GitHub, there's like a bunch of new EIP PRs, and you review them. And if they meet all the requirements, like they have a link to Ethereum Magicians, they have an author, the author has a GitHub handle, the security consideration sections actually talks about security stuff broadly. Then you approve the PR, and if not, then you kind of tell them what's wrong and go with them over and over. So that's high level what it is. And the time commitment, can vary. Like I think an hour a week is probably what like the minimum we'd expect for somebody, just because of the overhead of having to like, maintain contact with that person. I don't think, I think if you wanted to spend full time on this, there's a lot of like projects, like we talked about, like splitting out EIPs and ERCs and whatnot. Like there's a bunch of like projects that might take up more time, but EIP editing specifically is probably single digits hours per week across all the editors. And I think probably the most valuable part is like, if instead of seeing it as an hour a week, you see it as like 15 minutes per day, like it is valuable to be responsive to people. Yeah, that's roughly the commitment. So for a broad audience, what, if anything, do average maintenance app users need to do to be aware or watch for? The goal is like literally nothing. And that's really what we're designing for. So I think in practice, if you're a smart contract developer, there's a handful of smart contracts you might have to do some things, but they're like optimizations. They're not critical things you need to get done before the merge. If you're just yield farming on MetaMask, there's literally nothing that should change for you. I think the one thing that you can expect as a user is just like with any network upgrade, if you're using centralized exchanges, they'll probably have downtime for a few hours around the merge, couple hours before, and then make sure everything's all right and re-enable deposits and withdrawals. So there really shouldn't be anything different than like any prior network upgrade. Yeah. Oh, and yeah, Pooja has shared the EIP editor handbook in the chat. So I think that's, if you're interested in that, that's a really great resource to read, and will give you a lot of context.
Do we have any more questions out there? I guess while we're waiting to see if anyone else submits anything, someone did mention about, how to reach out, contact you guys. So if you want to throw in whether it's email or social media, how they can track you down, that would be good.
Yeah, I'm at Tim Beiko, TIMBIKO on Twitter, and Tim at Ethereum.org.
And I am at Pooja Ranjan, POOJARANJAN 19. That's my Twitter. And Pooja Ranjan at etherworld.co is my email.
All right. So it looks like we're wrapped up on questions. Anything else you guys want to add, or are we wrapping up?
All good for me. Yeah, thanks again for having us.
Pooja, are you good? Anything you want to mention there?
Thank you so much for the invite. I hope that these educational sessions help more people get on board and get the reference, they get up to date. Although there are other resources like blog.ethereum.org that provides the latest information. And Tim Beiko also writes a blog post about All Core Dev meeting. That is the best place to get more information about what's going on in Ethereum. And if you would like to join the community, we have Discord channel. So yeah, please feel free to reach any of us. Thank you so much.
Yeah, no, thank you, Tim. Thank you, Pooja. Great to see you guys again and have this information. And you attendees, we know your time is valuable, so you're taking time to meet with us. So we greatly appreciate that. As far as the EEA, if you'd like to learn more about the EEA, again, I'm James Harsh. I am the membership engagement specialist. So reach out to me. You can find me on LinkedIn. Check out our website. As we mentioned, this recording will be on our EEA YouTube channel, so feel free to check that out for all our other previous interesting materials. You can check us out on Facebook, Twitter, find us anywhere, but we'd love to share more information about the EEA and how we're helping to grow the overall community. So again, Tim, Pooja, thank you very much. Thank you, attendees. So this will wrap up today's EEA educational webinar. Thank you very much for attending and have a great week all.
Thanks.
Thank you.